Hi, my name is Quinn Burlingame, and I'm part of the 2019 class of Arnold O. Beckman Postdoctoral Fellows in Chemical Sciences. I'm currently at Princeton University in the Andlinger Center for Energy and the Environment, where I work as an associate research scholar in Professor Lin Lu's research group. My research focuses on the development of novel solar technologies to complement existing technologies like silicon. In general, that means for us we work on organic molecules, which are carbon-based, and perovskites, which are a new class of solar absorber that's really blown up over the last 10 years. The reason that we're looking into these technologies in particular is that silicon is a very well-established technology. The solar cells you might see on roofs or on the top of the parking structures here on campus in Princeton or out in solar fields, those are all based on silicon. And the reason for that is because it's relatively inexpensive. Those cells will last for 25 to 30 years in the field. They're very long-lived and stable. And they're quite cheap to manufacture at this stage where they've been commercialized for a long time. So if you want to make another solar technology to either complement or find niches that silicon can't, that's what we're really interested in. If we think about what our society is going to look like, what it's going to continue to look like over the next several years, I think urbanization is going to be a big part of that and has continued to be a big part of that for the last several decades. Urban spaces are generally a challenge for solar cells and for electrification because you want a solar cell to sit as close as possible to the application that you're going to be using. So you want that solar cell to be on your roof to power something in your house. And if you look at what an urban landscape tends to look like, you have large buildings, there's a lot of glass. The roof of a skyscraper, for example, is very small compared to the volume of that whole building. So that paradigm of solar generation doesn't work nearly as well. Some of the ways that you can help correct for that is to develop new technologies that fit into that paradigm. And one of those is transparent solar cells. So if I look at a skyscraper that has all this glass on the side, I can take transparent solar cells and I can collect a ton of solar energy from each face of that building, giving me a bunch of energy that I can use locally to cut down on carbon emissions from getting that energy from other sources that are less green. The other thing we can think about is the top of that building could be coated with non-transparent solar cells, opaque solar cells made of silicon. But really you want to maximize the power of that real estate because you have a small fraction of your building which is actually roof. Actually increasing the efficiency of silicon is a big benefit in an application like that. And one of the ways you can do that is by taking a transparent solar cell that only absorbs parts of the spectrum that silicon doesn't absorb well. So for example, we can take a transparent solar cell that absorbs near UV light and some blue light, and we can put that on top of the silicon cell. And then the silicon will harvest the red, the near infrared, and the green portions of light very efficiently. And the solar cell on top will take care of those high energy photons that are blue and near UV, and it will turn that into an overall module with a higher efficiency than the silicon could achieve on its own. So you really get more bang for your buck on that real estate on the tops of buildings. Being a part of the Beckman legacy means a lot to me. I think Dr. Beckman and I took sort of opposite paths. He started as a chemist, eventually found his way into Bell Labs, and even though he came back and finished his PhD in chemistry at Caltech, his career was really changed by all the electronics work he did to develop all the instrumentation that he developed. So being an electrical engineer myself, really what I wanted to get out of my postdoc is to understand more holistically these other scientific disciplines that go into the technology I love, which are these emerging solar cells based on organic and perovskite materials. So what the Beckman Foundation gave me the opportunity to do is to take that time to learn and to understand and to build up my chemistry chops and really make a difference across the spectrum from chemistry to device engineering to physics to really look at these devices as a whole and understand things in new ways and make new discoveries and new developments that just simply wouldn't have been possible with my purely electrical engineering background. A big piece of wisdom I think I've learned from learning about Dr. Beckman over the past couple of years is his investment in technology and in instrumentation. I think that is such a true fact that the pace of science really is determined by the instruments we have, these hands and eyes to basically look and touch the tiny microscopic world. Basically in the same way that telescopes revolutionized astronomy for hundreds of years, we're now at a revolution that he really was at the forefront of, where we can use those tools that he's helped develop to look at tiny nanoscopic objects, understand all these structure property relationships of new systems across energy materials, biological materials, and it's just a tremendous benefit to make instrumentation. So one of the things that I try to do in the lab is build instruments that are going to help us see things in a new way. I think it's a really kind of liberating way and a really creative way to go about science. And that's very much inspired by Dr. Beckman's work. For transparent solar cells, the overall transparency and color neutrality are really critical. If you're an occupant in an office who's looking out through a transparent solar window, you want the view to be unimpeded, you want it to be untinted, so you want lots of light to pass through, and you don't want any color coming into your view. Part of my Beckman-funded research has been to try to develop the most transparent and most color-neutral solar cells we can, and we've been successful in that in both organic materials and in perovskite materials. And to demonstrate just how transparent and color-neutral these solar cells are, we've actually been filming this portion of the video through the world's most transparent solar cell.